Welcome to this Java 8 session. My name is Delabassee. I work at Oracle. I'm coming from a country where we speak, amongst other language, German. So we speak German, French, and there is a third language. Anyone has a guess from where I'm coming from? German, French, Switzerland? That's wrong. I'm coming from Belgium, because it happens that German is also an official language in Belgium. So today I'm going to talk about Java 8. So we have released Java 7 a few years ago. Since then, we had a lot of solutions on the market, so a lot of solutions to choose from, either on the open source side or on the commercial side. But today I will really talk about the next version, Java 8. So this is me. A few months ago, I just focused in Sweden, and someone in the audience tweeted that it's not a real conference unless you read Oracle's safe harbor statement at least once. So please enjoy. So joke aside, well, you can read it if you want. Joke aside, I will talk about Java 8, which will be finalized in a few weeks from now. So things can still change. And at the end of the day, it's the different experts from the GCP who have the final say on what will be in Java 8. So what API, how they will look like, what capability they will provide, and so on. So that's something important to keep in mind. So that's my first disclaimer. The second disclaimer is that in this presentation, you will see some annotation. So if you have been attending the previous session, well, you've been warned. I will show you some annotations. Having said that, regarding the previous session, the speaker said that if you are using thread in a Java container, that's a very bad idea because it will fail. That's right. And in fact, it's forbidden to use thread in a Java container. That's part of the specification. So that's why we have introduced managed thread. So if you want to use thread, make sure to use managed thread, and you will not have the issue that was talked about previously. So let's talk about Java 8. So in the next 45 minutes, I will basically give you an overview of the new API and the new capability that we are adding in Java 8. So the first API that I want to talk about is JAX-RS. So in Java 8, we will have JAX-RS 2.1. At the beginning, the JAX-RS EG wanted to cover three main features for JAX-RS 2.1, and they decided some weeks ago to drop one, which is support for non-blocking I/O in the different JAX-RS providers. They did that because it was too early. So they have a prototype, but it turns out that we need to have Java SE9 to really provide that in a very nice fashion. And Java 8 is still based on Java SE8, so that's something that we cannot use in the specification today. So the two new big capability of JAX-RS 2.1 is a new Reactive Client API and support for server-sent event. So if you know JAX-RS, you know that in JAX-RS 2 we have added a client API. It works like this. So we first need to have a client container. So that's basically how we can get that instance. So it's basically a client container that we will use to issue REST request to a remote endpoint. So once we have the client container, we have to construct the request. So we first need to set the web target. So that's basically where on the network our remote endpoint is. Then we have to, from the web target, construct the request itself. So in this case, we will deal with a text plain media type. And then we have to actually invoke the request to get some result from the remote endpoint. So the thing that is important is that this get is blocking. So that means that my method will not return until I get some result from the remote endpoint. And as you'll see, at some point in time, you will have to make sure to close the client-side container. So that's basically JAX-RS 2 today, the client-side API. In JAX-RS 2, we have also added support for asynchronous client-side REST invocation. So to do that, you just need to invoke the asynchronous invoker. And to invoke that asynchronous invoker, we have an async method. And if you look at the previous example, you see that the return type is of string type. And if we are using the async invoker, you see that now we have a future of string type. So that means that we basically have an object that we can use to basically get at some point in time in the future our result. So this is not a blocking call anymore. Obviously, at some point in time, you will actually access the object itself. But the thing is that the get on the future is blocking. You can work around that by, for example, checking if you have actually something in the future object using the isDone method and so on. But still, it's not a really efficient approach. The good thing is that JAX-RS 2 is also solving that problem. So we have in JAX-RS 2 also an invocation callback that we can use to basically work around that issue. So it works like this. So obviously, this is an asynchronous invocation. So we have the async method. Then when we do the get method, when we are actually invoking the request, we pass it an instance of an invocation callback. The invocation callback has two methods, the completed, so that one will be invoked whenever we have the result. And the second one is the fail callback that will be invoked if something goes wrong. So that's something that you can use in JAX-RS 2. Now, let's put that in perspective by looking at this very basic microservices style scenario. So we have a travel agency services that will have to consume multiple, 4 in this case, backend services. So the scenario is as this. So we have a user that comes in. The travel agency services will first query a customer services to have the history of that user. Then, based on that history, the travel agency services will invoke a destination services to get some recommendation for that user. And once the travel agency services has a few destinations to recommend, it will invoke for all the destination a weather services to get some weather information and a quoting services. So the idea is that the user comes in and the travel agency services would like to propose some destination to that user with some pricing information and some weather information. So that means that the travel agency services has to basically implement some kind of orchestration to basically invoke the different services. Because obviously, for example, you will not invoke the destination services before the customer services. And the same is true. You first need to have the destination before going to the weather or to the quoting services. Obviously, in terms of performance, you don't want to do that in a blocking fashion, in a synchronous fashion. That would be just inefficient. So we want to do that in an async fashion. This is a very simple scenario, but let's simplify it a little bit further. So let's just pretend that we have 2 backend services. So if we are going to consume those backend services using the JAX-RS 2 async API, we would have to do something like that. So it's an async request. So first, we want to get some potential destination. So given that it's an async request, we will pass it an invocation callback. Invocation callback that needs to have 2 callbacks. The first one is the one that will be invoked when we have the result. In that one, we will basically go over all the destinations that we have received. And for those destinations, we will do another async request, this time to the forecast services. Given that it's an async invocation, we need to pass it an invocation callback, and so on and so on. We also need to make sure that we deal with the error, so we have to deal with the error callbacks. So I guess that you see where I want to go to. Even though this is a very basic scenario, the code to achieve that scenario, so to basically write that orchestration scenario is really difficult to write. So difficult to write means difficult to maintain, difficult to debug, and so on. So that's not something that we want to do. So it turns out that the async API that we have really works well if we don't have dependency between the services that needs to be invoked. But as soon as we have some dependency between those services, we are clearly observing some limits. And that's basically what is being solved in JAX-RS 2.1 with this new reactive asynchronous API. So we have a third invoker, RX, in JAX-RS 2.1. And you see that now the return type is not a future type, but it's a completion stage. Completion stage that has been introduced in Java-EE 8. So that means that now we can do something like that. So we first do an async request using this RX invoker. You see that I have a completion stage of number. We do a second request. Again, it's a reactive async request. And then it's basically just a matter of using the completion stage API of Java-EE 8 to define the workflow, the dependency between those different services invocations that are done in an asynchronous fashion. So in this case, we are just doing, given that we are using the then combine, we are doing the 2 requests in an asynchronous fashion in parallel, and we wait to have the result, and that result will be passed to that bConsumer reserve if affordable. So with that new Rx invoker in JAX-RS 2.1, we can finally easily write complex services invocation where you have dependency between the different services. So in terms of performance, it's not necessarily faster than the pure async version, but clearly it helps in writing the code. So in Java 8, JAX-RS 2.1, we are supporting the completion stage API of Java EC8. But the spec is open because we know that there are other solutions out there. So, for example, in Jersey, which is the reference implementation of JAX-RS, we plan to also support Rx Java, Guava listenable features, and maybe others. We'll see. So that is the first things that is part of JAX-RS 2.1. And then the other big feature of JAX-RS 2.1 is support for SSE. So SSE is not new. This is basically a standard means for pushing from the server side payload to the client side. So the client establishes the connection, and as soon as the connection is established, the server has a mean to push in an asynchronous fashion payload to the connected client. So we're adding support for SSE on both sides of the connection, so that means on the server side, but also on the client side. So JAX-RS 2.1 is introducing a super interface, which is called SSEvent, and that super interface is extended by two other interface, outbound SSEvent and inbound SSEvent. So one is the server-side view of an SSEvent, and the other one is the client-side view of that same event. So given that it's a one-way protocol, that means that you will have the ability to create event on the server side, but obviously on the client side, you cannot create event. You will just have to consume events which are coming from, which are being sent from the server. Then we have a new object that basically represents the connection between two SSE endpoints. We have SSE event sync, which is the server-side view of an SSE event. In JAX-RS 2.1, we have the ability to basically group different connections together. So the group to have a collection of different SSE events synced that is called a broadcaster. So the thing is that if you send some payload to one event sync, only that client will get it. If you are sending that same payload to the broadcaster, all the event sync of that broadcaster will get that payload. So how it works? So we have a method for which we have to inject at least the connection, so the SSE event sync. In this case, I'm also injecting another object, SSE. It's a convenient object that I can use to basically simplify a little bit my code. Then we are just using the standard JAX-RS client, the standard JAX-RS annotation. It's a get SSE endpoint that is, it's passed on the network, and it will produce that specific SSE meta type. So this is the server-side view. So that means that at some point in time, obviously, I have to send some payload to the connected client. To do that, I'm using the SSE object, which I have injected there, and I'm just invoking the new event on that SSE event to actually create an event that I can then send to my connection. I can do that multiple times, and obviously, at some point in time, I will have to close my connection. So it's really simple. On the other side of the connection, we also have an object that represents the connection now between the client and the server, and it's called an SSE event source. So we are leveraging the the JAX-RS client-side container. So we have this client-side container. So we have to construct a connection to our remote SSE endpoint. So we need to set its web target. We have the ability to configure a few things like the delay for trying to reconnect if the connection has been dropped, and so on. And then we actually need to invoke the build method to construct that object. Then what we need to do, we have to register a few callbacks. So the first callback, and the one that I need to make sure to register, is a consumer of inbound SSE event type. So that is basically the guy that will be invoked when some payload are being pushed on that specific connection. I have the ability to register other consumer, like a consumer for throwable, that will be invoked if something goes wrong. And then what I need to make sure, I need to invoke the open method on my event source. So that is basically where I tell my JAX-RS client-side container that I want him to open the connection and establish and register the different callbacks. And as soon as I do that, anytime some payload will be pushed by the server to my client side, my consumer will be invoked automatically. And obviously, at some point in time, once I'm done, I need to make sure that I actually close the client-side container. So SSE and this new RX invoker, so the reactive invoker, are really the two main new features of JAX-RS 2.1. But having said that, there are other new features that has been added in the specs, like, for example, having the ability to set the order of the providers that you have in your application, support for patch on the server side, and so on. And something that JAX-RS 2.1 is also doing is supporting JSON-P 1.1, which is part of Java 8, and it's also adding support for JSON-B that is being introduced in Java 8. So let's talk about the JSON support that we are doing in Java 8. So the first API is JSON-P 1.1, so it's an update of the JSON-P API that we have added in Java EE7. And basically, it's about supporting new standards that are emerging in the JSON space. So the first one is JSON pointer. As the name implies, a pointer is basically a syntax that you can use to point within a JSON document. So it works like this. So I have a contact JSON-P object whose JSON representation is on the right side. So if I want to use a JSON pointer on that object, I first need to create my pointer. So, and I'm using that syntax, so /0/name. So basically mean /0, that's the first object, so index 0, and then in that JSON object, JSON array, I want to have the key value whose key name is name. So I'm talking about Duke. So I have my pointer, so that means that I can do something with it. In this case, just a get value. So in this case, I will just get Duke as a return. So there are multiple operations that we can use with JSON pointer. We saw get value, but we also have some basic CRUD capabilities, so add, replace, and remove. So this is an example of a remove operation. Given that it's a remove operation, it's a replace operation, sorry. Given that it's a replace operation, I have to specify what the new value will be. And something important to keep in mind, the JSON-P API is an immutable API. So that means that once I'm doing my replace operation, the object that I get is a new object. It's not the original object which has been changed. So another standard that is part of JSON-P 1.1 is JSON patch. Again, a very obvious name. A patch is basically used to modify a JSON document. And it also happened that the patch in itself is a JSON document. So basically, a JSON patch is a JSON document that contains one or multiple operations that will be applied to a different JSON document to basically modify that document. The patch is atomic, so that means that if one of the operations fails, the complete patch is aborted. So let's see an example. So in this case, I have a patch with two operations. The first one is a replace operation, and the second one is the remove operation. The syntax that we are using here is obviously the JSON pointer syntax that we just saw a few minutes ago. So if we want to apply that patch to that target, so to that JSON document, so the first operation will be applied. So /0/phone/mobile basically means the mobile phone of Dukes. So we want to replace that key value. That works. So it moves to the next one because the patch is atomic, so that works. We can go to the next operation. And this is a remove operation. So if we apply that operation, that basically would be the end result. So this is the JSON view of JSON patch. Now let's look at how to use JSON patch using the JSON-P 1.1 API. So first, we need to have a target on which we want to apply the patch. So a target is in itself a JSON document. Then we need to have a patch. Again, a patch is also a JSON document. And from a JSON document, we can create the patch. That's what we do here. And then it's just a matter of applying the patch to the target. And we are done. The thing that we also have in JSON-P 1.1, we have this builder-based API where it's a fluent API. So basically, you can dynamically construct on the fly the patch. So you don't have to create the patch through a JSON document. You can directly construct the patch using this API. And obviously, you need to make sure to apply the patch to a target to actually get some results. So that's something which is quite convenient. Something else which is part of JSON, sorry, I forgot to mention, there is a third standard which is also supported in JSON P11. It's called JSON merge patch. So it's basically a different way of applying a patch. But in JSON P11, we also have the reverse operation. So basically, a patch is used to modify a document, but we also have the reverse operation, which is a diff. So we want to get the difference between two documents. And this can be used with the JSON merge API or the merge patch API. So that's something which is quite convenient. Then something which is part of JSON P11 is this. So this is pure JSON P1.0 code using Java-SE 8. So we are using the stream API, and you see that my terminal operation here, I basically have to construct my own collectors because JSON P.0 doesn't have any JSON collectors. Sorry, wrong direction. This is now solved in JSON P11. We have specific JSON collectors. So it simplified the code that we have to write. So that's a short overview of JSON P11, and there are additional capabilities that I really don't have the time to talk about today. So let's talk about JSON-B. This is a new API that we're adding to Java EE. It is to JSON basically what JAX-B is to XML. So it's basically an API that you can use to marshal and unmarshal Java object to and from a JSON document. So the API is basically providing a default behavior, a very common behavior. And obviously, you as a developer have the ability to override that behavior. So this is an example. So we have a list of phones. So it's a plain old Java object. And if you want to convert that object to a JSON document, all it takes is this. So we first need to have an instance of a JSON-B object. So you see that I'm using the JSON builder create. So I'm not specifying anything. So that means that I will obtain the default behavior. And then on that object, I'm invoking the toJSON method. And I'm passing it my Java object. And what I get in return is basically a string with that JSON representation. So the toJSON method support string as return type, but it also support output stream, writer, and so on. I told you that you have the ability to override the behavior. So if you look at the previous example, so for example, the key brand is basically derived from the setter and the getter that we have on the Java side. So we have set brands, so that means that our key by default will be brand. So if we want to have a different behavior, we can use one of the two annotations that has been added that is part of JSON-B 1.0. So in this case, by default, my key name would be first name, but given that I'm using the JSON-B property, it would be name instead. And we can apply the annotation at different level. So there are many ways to override the default behavior of JSON-B. So for example, the naming strategy that needs to be applied. Maybe there are in some case a property that you want to ignore. What should we do with the dates? What should you do if you have null values, and so on and so on. So this is part of the API. You have the ability to basically customize the way the JSON-B API will work. And to do that, we are introducing a new object. So this is a default behavior. I don't specify anything, so I will obtain the default behavior. But there is a new object which is called JSON-B config that you can use to do exactly that, customize the way the marshalling and unmarshalling to and from JSON will work. And the thing is that once you have your object, you pass it to the instance of the JSON-B object that you're creating, and you will obtain the default behavior. Now, something else that I didn't mention, and that's the key of that API, is the fact that you might say there are already a lot of solutions existing that basically provide JSON binding, and that's true. So we don't want to reinvent the wheel. The JSON-B API is really a standard API that is sitting on top of existing solution. And you, as a developer, have the ability to basically choose which JSON binding solution, which frameworks you want to use. And to do that, you just have to specify when you are creating your JSON-B instance, which JSON-B provider you want to use. So this is just a standard API that is sitting on top of existing solution. Obviously, we will provide a reference implementation that is called Eclipse JSON, but you have the ability to choose. Let's move on to a big feature that is part of Java 8, and that is adding support for HTTP2. That's something that we will do in the Servlet 4 API. Now, I don't really have the time to go in details about HTTP2, but HTTP2 is really about reducing the latency of web application. HTTP 1.1 was a text-based protocol. HTTP2 is a binary-based protocol. And in HTTP 1.1, when your client has to fetch multiple resources to render a page, for example, at some point in time, the client has to open multiple TCP connections, which is very expensive and highly inefficient. It's expensive on the client side, but also on the server side. In HTTP2, given that we have a binary protocol, the client will establish one physical connection to the server. And on that connection, then we can have multiple logical connections, which are called streams. So that means that everything can happen over that single physical connection. So that's something which is really important. So HTTP2 is about reducing latency of web application. And then something which is key about HTTP2 is the fact that HTTP2 doesn't define anything about the HTTP semantics. So basically, HTTP2 is using the HTTP semantics that you have been using for years. So you take an existing application, you deploy it on top of a Servlet 4 container, and it will just work on top of HTTP2. So it's true, except if you want to use one of the new features that is part of HTTP2, which is called server push. So server push is basically about giving the ability for a web server to proactively push resources to a client. So today, with HTTP 1.1, the client do a request, and the server will answer with one response. In HTTP2, the client do that request, that single request, and the server has the ability to answer with one or multiple response. So the idea is that it's something that the server can use to proactively push resources to the client. So basically pre-populate the cache of the client before the client knows that it will in fact need those resources. So if you want to do that, you will have to change your code. So first, server push is not about giving a means to a server to push in a completely asynchronous fashion resources to the client. There should always be an incoming request. And then the server can decide to answer with just one response or multiple response. So we always need to have an incoming request. That's what we have here. So from that request, I need to have a push builder object. So new push builder will return me a push builder object that is tied to that specific incoming request. Then I have the ability to set some headers that will be attached to the response that will push the resources that I will proactively push, in fact. And then what I need to make sure, obviously, to set the path of the resources that my web application wants to push. Then I just have to call the push method. So this is basically to tell to my servlet container that I want these resources to be pushed to the client. Now, there is no way to know if the resources will be effectively pushed. For various reasons, like the fact that the client can just decline the resources, or it might be that the resources is already in the cache of the client. We don't know if the resources will be pushed. So we shouldn't assume that because we have pushed the resources, that it will be on the client side. That's something that, that you need to take in mind when you are using the server push API. So server push and HTTP2 is really the main theme of the Servlet 4 API. So something important to clarify, this is server-side HTTP2 support. It's not client-side HTTP2 support. So it's really the main feature of Servlet 4. But having said that, there are a lot of new, smaller features that are also part of the Servlet 4 API. Like, for example, support for the HTTP trailers, or this new mapping discovery, those kind of things. So a lot of smaller features, but nevertheless, Servlet 4 API is really a big deal for the Java EE platform and the server-side Java world in general. Something else that we're updating in Java 8 is the Java Server Faces API. So in Java 8, we have JSF 2.3. So in JSF 2.3, there are a lot of nice new features that will basically improve the way you are using JSF. Like, for example, something that is part of JSF 2.3 is automatic support for HTTP server push. So if you have a JSF application, you don't have to change your code to benefit from the server push capability that are provided by HTTP2. That's part of JSF. Improved CDI integration, support for Java EC8 date and time API. We also have a new GSF WebSocket component that you can use to push from your GSF server-side application payload to the client without having to use any WebSocket API. So at the end of the day, we have a lot of nice features that basically will help you to write your GSF application. Now, let's talk about an API that is also part of Java 8. This one is led by Red Hat, and that is CDI2, Context and Dependency Injection. So the main theme of CDI2 is, at the end of the day, not that much important for us Java developers. Why? Because JSF2 is basically about improving the adoption of CDI outside of Java EE. So there are a lot of people that would like to use some part of the CDI specification in a pure Java SE application. But the thing is that CDI until CDI2 was basically an all or nothing approach. And if you look at CDI in itself, the specification has a lot of features. So we have dependency injection, we have context capability, we have interceptors, we have event capabilities, and so on and so on. So at the end of the day, you have a specification that is quite large. That also means that if you are going to use that on top of Java SE, you will have to use a CI container like Weld, which happen to be also relatively heavy. So that's why they would like to solve, and they are solving, in fact, in CDI2. So the way they have done that, they have split the specification in three. So we have CDI core. On top of that, we have CDI for Java SE. And on top of that, we have CDI for Java EE. That's what we are consuming on the Java EE side. We're basically consuming all of CDI. So that's one thing. What they have also done is they have standardized the way you can bootstrap a CDI container in a pure Java SE environment. Again, that's something that is not really important for us because that's something that is being taken care of by the Java container that we are using. So we don't really mind at the end of the day about those new capabilities that are part of CDI2, but nevertheless, they are very important. Now, doesn't mean that because CDI2 is really focused on Java SE, that there are no new features for Java developers. So I will cover two very quickly. The first one is I will quickly talk about the event capability that we have in CDI since the beginning. So since CDI 1.0, we have a very effective producer-consumer patterns implementation that we can use to basically play with event in our application. So it works like that. So we have to inject an event of some types. Then when we want to raise an event, we have to invoke the fire method on that specific event. We have the ability to pass it some payload. So here, I just want to fire an event. And then somewhere else in my application, I will have at least one observer. So that is basically the guy that will consume the event that has been produced there. And to specify that this is an observer, I will use the @observe annotation. Obviously, my observer has the ability to get the payload that has been attached to that event. So that's something which is not new. That's part of CDI 1.0. Something else which is not new is that we can have one or multiple observers. So that means that we can have multiple observers listening on the same event. The thing is that if you have multiple observers listening to the same event, there is no way to know in which order they will be invoked. It was up to the CDI implementation to basically decide that. In CDI 2.0, we have the ability to set the order using the @priority annotation, which is part of the common annotation. Now, there is a trick. So this is really not about setting the priority. This is really about setting the order. So that means that priority 10 will have a higher priority than priority 20. So lower the number is, higher the priority is. It's just a trick that you need to keep in mind. So that means that an observer will be invoked before another observer. Something that I need to mention, this is synchronous. So that means that the observer are called in the same thread as the firing thread, as the producing thread. And that's something that is also tackled in CDI2. We have now async event. So it works like this, exactly the same way, but instead of using the fire event, we are using the fire async event. So this is basically to tell to my CDI container that I want to shoot an event in an async fashion. And then on the consuming side, I also have to use this new @observed async annotation to basically specify that this is an asynchronous observer. So as soon as I fire my event, first my method will return. This is an unblocking call. This is asynchronous. And then in a different thread, my observer will be invoked. So something that I didn't show on my slide is that when you fire an event, you also have the ability to get in return a completion stage that you can basically use to implement some kind of workflow, some async workflow. You also have the ability to pass it on executor services. So you want to tell to the application server basically in which thread that observer will be executed, and so on. So this is something which is new in CDI 2. The thing that is not defined in CDI 2 is the ordering of async observer. Given that they are async, we're not sure if it makes sense. So let's talk about quickly bin validation 2, which is part of CDI, which is part of Java 8. It's the second specification that is led by Red Hat. So the main goal of CDI of bin validation 2, it's basically to use the new capabilities that are part of Java AC8, like supporting the validation on the new date and time API, having the ability to repeat constraint validation using repeatable annotation, and so on and so on. And then they're also looking at adding new constraint validation. So right now, this is more or less what will be part of the specification, because that specification is more or less done. So not empty, not blank, email, positive, positive or 0, and then negative, and negative or 0. So that's basically what bin validation 2 is about. And then there's a new API that we're adding to Java EE8, which is JSR 375, security API for Java EE. So the fact that we're adding a security API for Java EE doesn't mean that Java EE was not secure before. But the thing is that, so basically Java EE is secure since the early days. But the thing is that, first, the security capabilities of the platform were not really portable across different application servers. So that was one issue. And then it was sometimes kind of difficult to use some of the security capabilities that we have in the Java EE platform, like JSpeak, for example. So JSpeak is a very powerful API, but it's also a complex API, so it comes at a cost. So the goal of that JSR is basically to try to solve those two issues. So making the security concern portable across different Java EE application servers, and also simplifying how you can basically secure your Java EE application. So for example, what they are doing in that API, they are introducing the notion of an identity store. So until now, you had the ability to basically manage user in a Java EE container, but it was application server specific. Now with that identity store API, you basically have an abstraction that you can use to deal with your user across different application servers. And obviously, the identity store is just an abstraction, and it supports LDAP, database, and so on. So it's basically some kind of JDBC, if you will, but not for a database, but really for a user store. Then we're also introducing a new authentication mechanism that is using that identity store. It's something that is for web application in the first place. This is something to override the fact that JSpeak is very difficult to use. So we have a programmatic API now that you can easily use to basically secure your web application. That is part of that new authentication mechanism in that JSR. So that's the second API that we're adding with JSON-B to the platform. So let's wrap up, and then I want to do a very quick demo if I have time. So this is Java EE8. So in blue, this is a different API that we're updating in the platform. So today I give you a very quick overview. So we've talked about the Servlet API, Servlet 4 with HSP support, CDI 2, bin validation 2, and so on and so on. In orange at the bottom, those are two brand new API that we're adding to the platform, the JSON-B API and the security API. Now, what is not reflected on my slide is the fact that some of those API, like GPA, for example, or interceptors, are also updated for Java EE8. But this is done through a lighter process, which is called a maintenance release. So where are we? Well, some API are already done. So CDI is done, JSON-B is done, GSF and JSON-P are done. So basically, API are finalized. So we still have work to do on Servlet 4, JAX-RS, and security and bin validation, but clearly we are really getting towards the end. Once this is done, we can finalize the platform GSR, the Java 8 platform specification. And we want to do that this summer. So this summer, we want to have Java 8 final. So that means that all the specification, including the Java 8 specification, should be finalized. Shortly after that, we will have Glassfish 5, which is the open source Java 8 reference implementation final too. So that basically means that Java 8 should be done this summer. Having said that, what we did recently, we have basically moved all the Java development and the Glassfish development on GitHub. So in the past, we were on java.net. Too bad for us. Now everything is on GitHub. So today you can already use Glassfish 5. You can use either nightly builds or promoted builds of Glassfish 5 to start to play with all those API, because basically the integration is more or less of all those different API is more or less done. Obviously, we still have works to do to make sure that everything works correctly, but that's already available today. And then what we're also doing, we're providing image of Glassfish 5 on so Docker image. Once we will be final, those images will be on Docker Hub. But in the meantime, we are providing Docker files on GitHub directly that you can use to easily construct your Docker image using Java 8. So I have a few minutes. I just want to show you a very quick demo using Glassfish 5. So this is basically Glassfish 5. So it's a 2 days old build. I have one application running here. It's called Link. It's a very stupid application, but nevertheless. So it's exposed on 2 ports, 8080 in clear and 8181 over TLS. So I will go to that one. So localhost, link. So this is my application. I told you it's a very stupid application. So what it basically does, it displays one picture. But in fact, this picture is composed of multiple pictures. So for example, if I click here, so this is the kind of pictures that we have. And in fact, this is a matrix of 20 pictures by 20 pictures. So this is basically the number of pictures that the client needs to fetch from the network to basically display that pictures. So here it says that it takes 0.1 seconds. It's because I'm not using the network. So I will go over the network. So, and not only that, I will also use a proxy that will basically put my connection to ISNI. So basically, I will have a very bad connection. So I will reload that one. So this is over HTTP 1.1. And you see that fetching 400 pictures is first a bad idea, but it also takes a lot of time. So it basically takes 10 seconds. Now I will do the same, but this time I will go over the TLS port. I will go over the network. To make it fair, I say the networks. So it goes over the networks. So instead of taking 10 seconds, it takes 4 seconds. Yeah, 4 seconds. So this is one of the benefits of HTTP2. And to do that, all I had to do, I had to take my very stupid application and deploy it on top of Glassfish 5. And not only it's faster, but HTTP 1.1 was a clear connection. And if you look here, my HTTP2 connection is a secure connection. So it's how it takes to take basically your existing servlet application and upgrade those applications to support HTTP2. You just have to run them on top of a Servlet 4 container. Obviously, if I'm going to use the server push API, then I would have to change my code for that. So, the last thing that I want to mention, please contribute. Even though we are very late in the stage, if you have feedback to provide, we still have a few weeks to fix things that you think are broken. So please contribute. And also, you can also contribute by writing samples, for example, using the different Java 8 APIs. There are a lot of ways that you can help us to basically promote the Java 8 platform. And I will conclude by, well, I will not dare to pronounce that. So basically, thank you.